Okay, so we have a continuation of continuity. So we're still talking about what is continuity, when do we have it, when do we not have it? And we did our foldable on Friday, and we're going to just go through some topic questions and crank out some con today. So really nothing new. You had some notes to take to work with continuity on piecewise functions, basically. So, so we know these things from the notes. A function is continuous at an X location if you don't have to lift your pencil or draw it, right? That's the kind of the definition using common terms. A lot of times easier to find a discontinuity. So kind of disproving it rather than to prove a function is continuous. So it's really important to know when they are and know how to find them, what they are. So I put the types of discontinuities up on the wall that you discovered and you diagrammed in your notes. So we have our removable ones, we have our jumps, and our infinite or asymptotes, and our oscillating, which is really rare. So anytime you have a hole in the graph, if all it is just this hole, right? That's kind of what you're doing on the piecewise functions in the notes for today. And so that makes them removable. And this last one, the essential discontinuities, they use that term. So I just kind of had to throw it out at you. The essential discontinuities are those jumps and asymptotes and oscillations. We can't remove them. There's nothing we can do to rewrite them to make them continuous. So those are those things. Okay. So a couple of quick comments about the takeaways. So here's kind of a mathy way of saying not having to lift your pencil, right? Left hand limit and the function and the right hand limit are all the same value. So we're all coming together there, not to have to lift our pencil. And remember that holes, you get holes by canceling factors. So you have this indeterminate form, you factor top and bottom and you cancel factors. That is getting rid of the hole. And then, like I said, there's a jump and infinite and oscillate. So any questions about that? Okay. So what is continuity? When do we have it? When do we not have it? Okay. So I stuck with the informal definition. A function is continuous at any location if you don't have to lift your pencil or draw it. We are on page 16 or 17 or something like that. Y'all doing really awesome with the con. Keep up the good work. Building some excellent college readiness skills. You can do that work the nights it is assigned. That's just awesome. Okay, so a function is continuous at any locations. If you don't have to lift your pencil, you don't have it when we have discontinuity. Okay, and then we've got those big four. We've got the hole, the jump, the asymptote, and anything it's oscillating that might jump horizontally because of some missing domain points, usually with radicals, but very rare. Usually it's just the hole and the jump and the asymptote we deal with mathematically. Okay. All right, so we've got some topic questions, and then we've got notes for tonight, and then we've got some con to do. So you've got the rest of the hour to bust those open, complete those. Keep up the good work. Keep doing what you're doing. And I'll be around to answer any questions you might have.